This walking talking mock covers 3.1.4, which is all to do with sorting algorithms. So our first question is saying that a bubble sort needs to be carried out on the set of numbers in figure 1. There's figure 1. How many comparisons and how many swaps will be required for the first pass? Complete the table below, and it's worth 2 marks. So we're assuming we get 1 mark for that one and 1 mark for that one. So bubble sorts, they work by doing a pass and keep doing passes until there aren't any swaps left. So just the first pass just means that it's going to go down this list once. To complete the whole sort, it would need to go through this pass, through this list, until there were no swaps left. So if we take a look at our first pass, we know that we're starting on the left hand side. We go from left to right, and we've got here our first 2 items that we need to compare. So one comparison is taking place straight away. So if I do a little tally chart here, I can keep track of how many comparisons are happening. Now this one here, it doesn't need to swap because it's already in the correct order. So I can keep it like that for now. So there were no swaps, so I don't need to put anything on my tally down there. Now the next lot is 16 and 10. So I'm comparing again 16 and 10, and I'm seeing if I need to swap. Now this time I do need to swap, so I'm going to put a 1 there, and that's because 10 is smaller than 16. So at this point I've got to put my 10 down and then my 16. So now I move on. So next comparison is actually going to be 16, because we've moved this now, and 11. So I'm going to compare 16 and 11. Do I need to swap it? Yes, I do need to swap it because they should be the other way around. So I'm going to put 11 and 16. So now I'm looking at 16 and 4. So I've got another comparison. I'm looking at 16 and 4. 4 is smaller than 16, so yes, we're going to have to swap. And again, I'm going to have to put 4 and then 16. And now I'm comparing 16 with 12. So I've got another comparison. Does 16 and 12 need swapping around? Yes, it does. So I'm going to move the 16 over here. And now I've looked at that. Now I'm working on 16 and 6. So I'm doing another comparison. Yes, it needs to swap because 6 is smaller than 16. And then I've got 7 left. So 16 and 7. So I've got another comparison. And do I need to swap? Yes, I do need to swap. So now the 16 moves over here. So if I wanted to write this out neatly, my first pass would get the data compared and swapped in this order. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So I've definitely gone through all of them. So I've got here 1, 2, 3, 4, 5, 6, 7 comparisons. 1, 2, 3, 4, 5, 6, 6 swaps. So they're my answers. So I could rub that out if I wanted to just make it a little bit clearer. But there's my answers. Our next question says that a bubble sort algorithm can be viewed as a simple algorithm to construct. What is the main drawback of a bubble sort algorithm? And it says explain your choice, and it's worth 2 marks. We've got this command word, which is to explain. And we're talking about a drawback of a bubble sort algorithm. So first of all, what is the drawback? Now, the main drawback is that it is inefficient. So a bubble sort algorithm is inefficient. And then we've got explain our choice. So I've got 1 mark for that, and then 1 mark for my explanation. So if you think about the example that we just did on the previous question, it has to go down each pass over and over and over again, making swaps, which can be extremely inefficient. So that is the main drawback. It's inefficient, and we've got to explain why. So this is because the data set will need to be read in full at each pass, which can use a lot of resources. Okay, so I've got my choice, so it's inefficient, and then I've got my reason, and I'll say that it's using a lot of resources. So that'll give me my second mark, so I should get 2 marks there. Our next question is looking at the divide and conquer algorithm. So it's saying, why is a merge sort considered a divide and conquer algorithm? And this is worth 2 marks, so we're looking for 2 points in our answer, and it's saying why. So first of all, divide and conquer is to do with breaking a solution down into small pieces, solving each small piece, and then putting it back together again. And that is what a merge sort does. If I've got a big list of data in a data set, it'll split it. It'll then split it again, and split it again until each piece of data is on its own, and then it'll conquer it, so it'll figure out the correct order that things should go in, and then it'll put it back together. So why is a merge sort considered a divide and conquer algorithm? A divide and conquer algorithm divides a data set into small pieces. It then conquers each small piece before putting it back together. This is how a merge sort operates. Okay, so we've now explained why a merge sort is considered a divide and conquer algorithm, because I've given a definition for a divide and conquer algorithm, which would give me my first mark, and I have explained it as well and why it links by giving it the second mark. The final question is, what is the first action performed in a merge sort? And you can see that it is worth only 1 mark, so we are going to give a short and concise answer to this question. What is the first action performed in a merge sort? So I've just explained that to you on the last question. So the first thing it does is it splits the data set repeatedly until each piece of data is on its own. And that's it.